Hello, everybody. Good morning, evening, whatever time it is for you. Uh, After what you just heard in Shakib's amazing presentation, I don't have any uh, responsibilities to explain why database designing is so important because he already mentioned that it was the first thing they did when they started with the application. So we talk about database designing, and this is especially for you Apex developers. Very briefly about me. So I have graduated from University of Helsinki with master's degree and currently working on my doctoral studies. I have been working on IT quite many years, especially with Oracle most of my career. Data and databases is very close to my heart, and that's why I think Apex is one of the coolest things, because it is about data and database. I'm a CEO for Miracle, ACE Director, Groundbreaker Ambassador. Something that amazes me every time is that I have been listed as one of the top 100 influencers on IT sector in Finland for 5 years in a row. And I'm really, really proud of that. I'm a public speaker and author. I have written 2 books and I speak in more than 20 events every year. The first book is about database designing, the topic we have today. And the second one is about SQL and PL SQL, co-authored with some other ACE directors. So I have been using Oracle Designer since very, very long. And then Oracle bought another product that turned out to be Data Modeler, and I have been using that since 2010. I have been solving performance problems for years. And during those years, I realized that actually it is much easier to solve the problems if the database has been designed and documented. And actually, there's less performance problems if the database has been designed. Also, something I noticed during those years, and I still do, is that if your database has been designed, actually, you will have better quality data. So if it's not been designed, your data might be not so good quality. And what's the point of having a database with bad data? A slide about the ACE program. I don't have time to go it through, but if you're interested about the program, I'm happy to tell you more about it. So why to design? Very briefly. When I go and see customers, they always tell me data is the most valuable property in our company. But yet they are not willing to design the databases because that will cost. Instead, they tell me that why do we need to design the database because we already designed the application? Well, actually, it is not the same thing to design the database and design the application as you already heard in Shakib's presentation. There are different points of views, saving and retrieving the data while designing the database, and thinking about the user interface, how the user is able to use more productively and better your application. It's a different point of view. Also, if you think about the database, it's not very often you can completely change the database. It's going to be 20, 30, 40 years that you will keep the same database. So you really need to think very hard to have a database that will last for so long. You can always change the user interface. That's something that your boss will allow you to do every, let's say, 5 years, 10 years, but you are not allowed to change the database because of the data in there. Also, when designing the database, you need to see the whole picture, not just increments, but the whole picture to be able to make the right decisions. There are also different goals or targets for the application designer and for the database designer. Like as a database designer, I want to have code tables for a kind of codes, while as some of the application designers might prefer having code files. It's easier for them for programming purposes. Luckily, in Apex, we all agree on having tables. How about analyses, reports, all these kind of things that will happen after we are in production? When doing the user interface or designing the user interface, you don't actually care about that. You only care about how we manage with the next increment. Something that is very confusing sometimes with database designing is the terminology, because we have the same words for application designing and database designing, but they actually mean different things. My favorite one is domain. That's something that we argue every time. So a lot of misunderstandings come out of that. So why should you model the data? It is actually to facilitate the communication about the requirements, to really understand what the requirements are. To find the questions, you should be asking the end users to understand what they really want and need. And actually a funny thing, to narrow the scope. Because when you start building an application, you would like to take everything and build everything and make the best possible application and the database ever. But when you start designing, you are narrowing the scope when you realize that actually we don't need that. and we already have that, and so on. So it's actually narrowing the scope. When you're designing the database, you don't design the whole world, just what you need for your application. Modeling is very difficult because the spoken or written language is not exact. And usually the important things are not said because everybody knows it. Why should I say it? You already know it. But I don't know it. I am not a business expert. I'm just a database person. So I need to know all those important things that everybody knows except me. And also at this stage, when we start designing the database, we don't know one important thing. How are we going to retrieve the data? What will happen in iteration 9 or 10 or 35? So we actually don't know how to retrieve data, and that is one of the main things we need to know when designing a database. But whatever troubles we have, modeling is mandatory, because when we model the database, we realize the questions we need to ask. I have been designing databases more than 20 years, and I still don't know the questions without modeling the database. So what is this database designing? Well, it's actually 4 or 5 phases. We do this over and over again. We start with requirement analysis, we go to conceptual design, we do logical design and physical design. And also transaction design is a very important part of database designing, but we don't talk about it today. What I have here, DM, means data modeler. In data modeler, we do requirement analysis in logical model. We do conceptual design in logical model. We do logical design in relational model. That's a bit confusing. That's why I put it here. And the physical design in physical model. So it would be crazy to do all this work without having a tool. And as a tool, I recommend you to use Oracle SQL Developer Data Modeler for many, many reasons. First of all, it's free to use. It supports many different databases. So if you're not using Oracle database for storing the data, other technologies are also possible. It supports both documenting the existing databases and designing a new database. This means that you can also do reverse engineering, which is a question I get often. And designing the database and maintaining the databases after you design them. It supports reporting, which is one of the top things I think for a tool has to have, because if you put all the important information in a tool, and then you don't get the information out, what's the point? So reporting is actually one of the key functionalities in a designing tool. Then you also have naming standards, glossaries, design rules, all kinds of things that will standardize your work and give you better quality of designing. It supports version control and multi-user environment, and it supports everything you need for database designing plus more. So I really don't see any point of not using Data Modeler. This is how the tool looks like. I think I will show it here. So what we have here is a design. Things here are called designs. I have one opened here, and I have a new design that I'm going to work on. This is the canvas where I work. This is the navigator that I will have for navigating through my canvas. Then I have versions. As you can see, Git and Subversion are supported version control tools. And then I have here message log, where it will tell me what's going on in the tool. I have all kind of icons here. Depending what I choose here, if I do logical or relational, the tools here are different. If I do logical, I have entities and I have relationships. If I do relational, I will have tables and I will have foreign keys. So depending what I do, I have different things available. Here, maybe the most important thing is tools. If you're looking for a functionality in Data Modeler, this is probably where you should go to. So tools is very important. Very briefly about the tool. So there are 2 things that you should know about the tool before you start using it. There's a thing called design properties or design level settings. So everything in this tool has properties. So the design has properties, table has properties, column has properties, everything has properties. So if you want to see the properties, you go to this browser that you saw on the left-hand side, you right-click or double-click, you will see the properties. For the design, you can also go to tools and design level settings. There's a slight difference between these 2, but I will show you what it is. So this is the properties. Every time you see the properties, there's also the general and comments, notes, and summary, while as in the design level settings, you will only see the setting part of this tree. So you will only see these. Design properties are something, if you change these and somebody else starts designing this particular database, he or she will have the same settings you have defined here. So this thing, design level settings or design properties, are design-wide for everybody using the tool. One of the most important things in design properties is templates. Here you can define the naming conventions that you're using in your company. So whenever the tool is automatically generating, let's say, surrogate key or index, this is the naming convention that will be used for generating it. So this is something that you should take good look before starting to use. Another thing you should be aware of is preferences. You find it from the tools menu. Preferences are computer-wide. So if I change here in my computer the preferences, you will not see them. So you need to get a copy of my preferences to your computer to be able to have the same set of preferences. And this is something you should also decide in your company how to do it. Preferences are in different levels: environment, data model, format, version, all different kind of preferences. And I encourage you to take a good look at all the preferences that there are in the tool so that you will have the right setting for your company. There are also some settings that are defaults. This is not important to do in the beginning, but when you use more of this tool, it gets annoying when it's always suggesting you that you are doing a DB2 database instead of Oracle 12c. So here you can define what is the default databases that you're going to be designing, or you can define your preferred logical types. So there's a billion different logical types here in the list. You can choose from the list those preferred types that you would prefer using in your design, which makes it easier for you to design your attribute data types. So back to designing the database. It starts with requirement analysis. So you're finding and analyzing the requirements that those future end users have for the system and for the database. The result is specification of user requirements for data, functional requirements, security requirements, performance requirements, backup recovery requirements, all of requirements they have for the system. Then we move to conceptual design. I put these together because we use the same tool in Data Modeler. This conceptual design is interpretation of all those requirements to a formal presentation, a conceptual model. It's a conceptual schema, an ER diagram, and also some textual documentation I would recommend to make if you find more information that cannot be just in the diagram. So this is the tool for communication with end users. They do understand whatever you have here. So you collect requirements, you analyze them, you're doing fact-finding, interviews, questionnaires, existing documentation, and I actually recommend you do recordings during those sessions because it's easier to listen it again, because in the beginning, I'm not an expert of this particular business area, but when I hear the same answers the fifth time, I might even understand what people are telling me. So having the recordings is very good for me as a database designer. But also for those people who are answering my questions, it's good to have recordings because they take it more seriously. The boss might hear the recording, so they really give you better answers. So everything I do in this phase, it's completely neutral to any technology. So this is going to be some kind of data store that will have data. But I have not decided if it's going to be a relational database, a MongoDB, whatever it's going to be. It's going to just be a store for data. So I want to understand what kind of data is needed. Why I prefer entity relational model instead of just doing the tables immediately. Because if I define the tables directly based on the requirements, I actually find it too difficult and I make a lot of mistakes. And I end up having a wrong kind of DB schema. So ER designing is the best tool for database designing. And it's so easy to just generate the relational model based on it, the tables and the columns and the foreign keys. You can also do data flow diagrams, but I don't talk about that. That's about how the data is flowing through our system. when you're doing the conceptual design, use the right terminology and clear names, because it's much easier to communicate with the end users if you are using the right terminology. Try to find and understand the main concepts and how they are related to each other, because these are something that is very difficult to change in iteration 10 or 55. So try to find the main concepts and how they relate to each other. So let's see, what is a logical model? Logical model is the phase where you work the most. So this is 80% of your work. I start talking with my end users. They tell me, so we have those customers that actually make orders and and in the order they have products. Each product belongs to a product family, a product group, and when they make the orders, they have order lines, and so on and so on and so on. So they tell me a lot of things about their needs and their system, how it works and how their processes work. In general, when I hear nouns, I think it's either an entity or it is an attribute. So we have customers that has names, and those, okay, now I will actually talk about the domains. So I can use logical. You see there's a lot of different kind of logical data types. Remember, I mentioned you in preferences, you can say the preferred when my list is so much shorter. Another thing I can do to make my life easier is using domains. So I can define domains. For here, I have defined a domain name because I know I use a lot of names. In the domain definition, I define it's going to be a varchar 2 and the length is this. So I don't have to remember if I define money kind of attributes, how long it is. I know it's number, but is it like 15.2 or is it like 17.4 or what is the money usually in my company? So I can define domains and I don't have to remember it. Another thing is that after my design, we actually agree that name is not 50 characters, it's 150 characters. So I can just go and change the domain definition and everything will automatically change for those attributes and columns that I have defined using domains. So the next thing I do, I hear those nouns and I have to decide if this noun is an entity or an attribute. Then I hear verbs. They tell me a customer makes an order. Then I have to ask questions like, can customer have many orders? Can an order have several customers? And so on and so on. So I hear that customer can have a lot of orders. An order must belong to a customer, and customer does not need to have orders. It might have orders. Then I also hear that order line is so-called weak entity. So an order line cannot exist without being without having a parent, an order. By the way, I'm using back policy here now because I'm using singular and plural forms, which is not correct. But during this session with the end users, I just try to be very quick with my modeling. When I go back to my desk, I go and decide if I'm going to use plurals or singular form, and I will go and update my model. And I also noticed that during this session, I forgot to ask them, does every customer need to have a name? So next session, I will ask them. So you told me the customer needs to have a name. A customer has a name. Is it a mandatory thing to have? And they said, of course, we can't have customers without a name. And I will just add it here. And also during the session, I try to ask them questions that will give me the idea, what is the identifier of my customer? What is the identifier of an order? And so on, so that I understand what is this thing about. So actually, I have created this earlier to save some time. So we'll just open it here. And we end up like this when we finish the session with the customer and with the end users. So what was important here is that I can change the notation. So if my end users don't understand the notation we have here, I can go and change to Bachmann notation. Maybe this is more readable for them. Or maybe they prefer information engineering notation. I can also choose that. And this can be done as many times as needed during the session. That makes life much, much easier. I mentioned you the domains. So this is how to do the domains. You go to Tools, Domains, Administration, and you create your own domains. You define the name, the logical type, size, what units, what precision, what scale, and so on. You can also define check constraint ranges and value lists for a domain. And when defining the attributes for your entity, instead of choosing number here or numeric and the length, you choose whatever is your domain called. For this phase, there's also preferences. These are not very crucial, so this is not something you have to go and definitely look, but this is something that if you are used to do something differently, this might help you to adjust the tool for your preferences. The next step we move to logical designing. So we are transforming those conceptual things we just had to a logical data model and logical schema that the relational database management system understands. So we will have a relational database schema with tables and constraints. In this point, we have decided it's going to be a relational database. This is not going to be a MongoDB or anything like that. It's going to be a relational database. But yet we have not decided if it's going to be Oracle or SQL Server, whatever technology. But it's going to be a relational database. So moving from logical to relational is very simple. We have this logical design open here. We just created. We click here, this double arrow pointing right that says Engineer to Relational Model. There are things we can do while doing this transformation. We can use transformation scripts, which will change whatever comes out from the design. We can also do things that are already in the tool. So this is when I'm generating my tables and my foreign keys, engineer to relational model. I can also use a thing called template tables. Like if I'm doing a data vault, data warehouse solution, I have a lot of technical columns that I need to add to different types of tables. I can use these template tables. So in one template table, I define the columns that needs to be added. They can be mandatory, non-mandatory, and so on. So I define those in the table, a template table, and I choose here the template table, and all those columns will be automatically added. If I do it another time, I already created a table, and I want to do this again. If there are any changes, like in data type, in the column, or anything in my template table, it will follow that. And if no changes, nothing will change. So this is a good trick to do because technical columns are not something you want to design in your entity relation design. Things like who created the row, who changed it, when, and so on. This kind of technical columns. There's also preferences for this. For relational preferences are here. I don't go through them in details because we only have 45 minutes, but just to tell you where to find those preferences. I mentioned earlier this template for naming conventions, and this is what is used now. So when generating the tables, the primary keys, the foreign keys, and so on, this naming convention is followed by the tool. So let's see what happens. So we designed the logical database. I will just close these from here so it's not confusing us. So this is what we designed, and I'm going to press this double arrow engineer to relational model. It will tell me, the triangle is always something has changed. A green plus means this is a new thing, and a red cross means that this is something that should be deleted. So now it's telling me I'm going to have these entities as these tables, if you're okay with that. And they will have these attributes and so on. If I don't want to create this customer table, I will just deselect it, but I want to create everything. There's a lot of details you can see here, like if something has changed, you can see here the name change or whatever. So I will just engineer, and I end up having tables. So this is my relational model for the relational database. It has tables, columns, primary keys, foreign keys, and so on. This is what we got. So step one, check and see if you really got what you wanted. So go and check your tables, your columns. Is this what you wanted? If not, go back to your logical model, change whatever needed, and generate it again. Then you can do some general definitions or create some general definitions that are for every relational database, not technology specific. These are not things that you can do in this point. So only those that are for any relational database. For instance, just B-tree indexes are supported with any of those relational databases. You can create B-tree indexes manually, maybe for your primary keys and for foreign keys, or you can do it automatically using automatic index generation. If you use this automatic index generation, you will not see those indexes in the browser, but when you generate the DDLs, you will have the DDL for creating primary key or unique key or foreign key constraint indexes. So the next step we have to do is the physical design. So far we had the tables, the columns, the foreign keys, the primary keys, and so on. And if there were anything we needed to change, we go back to the logical model, we change, and we engineer to relational again. So now we do the physical design. This depends on what technology we choose now. Is it going to be Oracle 19c, DB2? Is it going to be SQL Server? What technology it is, because this is completely dependent on the technology. So depending on that, you have different things that you need to be defining. So it starts the first time you create a physical model, you right-click in physical model and you say new. Remember when we were doing the logical and the relational engineering, you always need to press the button. But for physical, you don't do it. You only do it once. So after you have said new, you already have the physical model done. And whenever there's something new in the relational model, a new column, a new table, a new something, it's automatically in your physical model. When you create a physical model, what you have to choose is what technology. It's called here database site. So what kind of database will be created? In the preferences, you can define some defaults. So I mentioned that whenever there's a new table in the relational model, it's automatically created in your physical model. But what table space or under what user and so on, you can define the defaults here in the preferences. So you don't have to go and manually do it. And of course, even though it uses the default, you can always go and change it manually. So let's see how the physical works. So we have the logical, remember the entities and the relationships, and we engineered to relational look at our tables and our foreign keys. So the next step is that we need to have a physical model. So a logical model can have one or several relational models, and each relational model can have one or several physical models. Why would I want to have several physical models? Let's say I have a wonderful database, but I have customers who some of them use Oracle and some use SQL Server. And I don't want to design the database twice for those two purposes because they're both relational database. The design would be exactly the same. So I can just create two physical models. I can create one model for my Oracle customers, and I can create another model for my SQL Server customers. Now I have created them. If I have a new table in my relational model, I will just make a trick here. Table 6 is a good name. It will be automatically added to my table. See, table 6 is here. So for physical model, I don't have to do anything to get my tables or columns in there. So let's see about the physical model. I just check if I had anything in the slides. So what we have to do now is all the physical elements depending on the technology we chose here. So if I see Oracle here and I take one of my tables, these are the properties that I should be defining. So these are the ones that I have create table clause for Oracle. If I do the same for SQL Server, it looks a little bit different. These are the properties I will be defining. So depending what technology you chose here, you have different options. But whatever you do, you have to define those physical properties. What is the schema owner? Well, I don't have any schemas here, so this is very stupid, but I will just choose here. And I don't have table spaces either. So you have to define the table spaces and whatever you need here, storage definitions and so on for all these. So what if I have so many tables? I have here like 200 tables, and I have to go manually define this user to each of my table, and I'm going to be very bored. There's a thing called propagate properties. So I can use just the user information here and copy that to all other tables I have. So I don't have to do it manually. So if I go and see now, oops, something went wrong with my, my demo here. But anyway, if I do it like this, so I just take this, I didn't apply it. So if I do this and I select users and I select all my elements here, it will be applied to all my tables. So I don't have to go and do it manually. The same goes with table spaces and so on. Propagate properties will be your best friend in physical designing. What I also have to do is defining the privileges, and hopefully in the conceptual design and the requirement phase, you already learned what kind of requirements they have for privileges, maybe some kind of user groups or something like that. So depending on the technology you chose, you have different kind of options here to do. Setting up the properties, we just saw that. Well, the point here for the whole thing was to get the DDLs out. So no point having anything else except the DDLs. Everything else here was just hard work. But getting out the DDLs, there's a thing called table DDL transformations that you can use to transform the DDLs that will come out. You might want to have somehow different DDLs that it will generate automatically. Again, there's a lot of preferences that you can use. There's preferences for DDLs itself, like do you want to include logging, or do you want to include schema name, or do you want to include storage, and so on. So using these, you can change how the DDL looks like. And this is very powerful. I hear a lot of people saying that I don't like the DDLs data modeler is generating. Yes, because you haven't seen the preferences. Go and change these and your DDLs will be much better. Also for comparisons, you can use some of these to change how the tool behaves. And the storage. So let's see how the DDL is created. So I didn't actually do everything I should have been done here, so my DDLs are not perfect. So it goes from here. So you take file, export, and DDL file. You decide here, I had two different physical models, so I could take the Oracle version or the SQL version of my DDLs, and I generate. I can define here if I want to have drops for my tables. I don't go to details on these because we have such a short time. You can define if you want to have all the tables or just some of the tables. This table I don't want to have. Do you want to have the primary keys and unique keys? Do you want to have indexes, foreign keys, and so on? Do you want to generate the DDL in separate files? So if I don't choose this, I will just have one file with all the DDLs. And if I choose this, I will have a folder structure with different kind of elements or objects for my database. But I will just choose like this. And I will get some errors. I will talk about design rules a bit later. So some errors that say that actually my design is not according to my standards. We'll see that soon. So anyway, I got the DDLs here. I can just save it. I will check it, and I'm happy with it. So I will save it. I check how it looks like because this is a generated file. There might be errors, as I saw in my example now. Then if I'm happy with my DDL, I connect to database using SQL Developer, and I execute my DDL, and always do it on test database first because you never know. Something useful you should know about Data Modeler. You saw the error messages I got from my DDLs. It says something about design rules. So there are design rules in the tools in the tool where you can define what are the rules for our design. Like identity entities always has to have attributes, or they cannot be a table that doesn't have columns, or they can't be a column that doesn't have a description, something like this. You can create your own sets or you can use this set. You can add your own rules if you want, but this set is actually pretty good, especially in the beginning. So I just say apply all, and it will check my design. In red, it will show errors. Customer has no comment in RDBMS defined, so comment has to be defined before I'm okay to continue. There's also warnings like a product primary key has a wrong naming standard. This is not something that is recommended. So I have used wrong kind of naming standard. So different kind of things. What is the best is that I can just go and double click here and it will take me to the place where this error exists and I can go and fix it immediately. You can do this check many times in different phases. Also, when you start generating the DDLs, there's a button that says design rules and you can check them before generating DDLs. There are different compares. You can compare a design to another design, a design to database, or database to a design. If you want to compare designs, you can do file import data modeler design. That compares everything. You have one design open and you are importing another one. It tells you how they are different from each other. You can use tools compare merge models that compares only the relational and physical model, so it doesn't compare the entities and their relationships. But the good thing is that it will give you the alter DDLs to modify the other one exactly to the same as the first one. You can also compare database. So if you use synchronized model with data dictionary, you're actually changing the model according to the database, or synchronized data dictionary with model when you are changing the database, depending what changes you have in the model. You can use file import DDL file if you don't have access to your database. So you have a design open, you import this DDL and it will tell you how the DDL database is different from your design. Or you can import from data dictionary when it tells you how your database and your design are different from each other. Has somebody added a new table in a database without designing it? Or do you have some designs you have forgotten to put actually to your database? There's also version control. As I mentioned already, Git and Subversion are both supported nowadays. Version control is amazing because now also a database designer is allowed to make mistakes. You can also always go back to the previous version or version 1.5 or whatever version of the database. And you can also see what's the difference between version 1.5 and 3.7. So in conclusion, there is no serious application without database being designed. So this is a phase that you have to do if your application is going to be used in a serious way. There's two versions of Data Modeler. There's the standalone version and the integrated version in SQL Developer. The one I used in the demos is the standalone version, and this is what I recommend you to use when you do database designing, and why. They both have the same functionalities, but the standalone version is easier to find whatever you need, because in SQL Developer, you have to go through so many menus to find whatever you are trying to do. So designing the database, use the standalone version. To be able to connect to the database and see whatever is in a database, you should use SQL Developer, and also for executing the DDLs we generated in the demo. So to design the database and maintain those data structures, use Data Modeler, and to design data architecture, also use Data Modeler and the standalone version. It's a good tool. It supports iterative processes. My life is much, much easier now with version control, with all those XML files. Everything in the tool is in XML files. It has nothing to do with the database, even though it's a database designing tool. So all the files are XML files. It enables documenting and versioning and comparing those versions to each other. Enables multi-use environment, so I can have several people working on the same design at the same time. It is free to use. This is something that I appreciate a lot. And it supports also other databases. So with the same tool, you can design different databases, not just Oracle. So I really see no reason to use it. And I am happy to answer the questions, and I did it in 41 minutes. So any questions?
Sure, Heli. So I have a few questions that are noted, so let me just pull them on. Okay, the first one is, does SQL Developer Data Modeler support MySQL?
Not actually. That's a question I get a lot. But you can make it support it, because I mentioned you about the transformations for DDL. So when you are generating the DDLs, you can actually transform. You choose the one that is the closest to MySQL, and then you make some transformations for the DDL script. And you are able to connect to do the reverse engineering with DDLs, especially. So you can make it support. And JavaScript is the key for everything with data modelers. So getting it support whatever you need is just JavaScript away from you.
Okay, so the another question is, we have unique prefixes to our tables. For example, AAA customer, AA border, AA co-author line, etc. Each of these tables column names will also start with these prefixes. Does data modeler support this?
Yes. So in a relational model here, you can define object name prefixes where you can define what prefix you want to have for what objects. So if I want to have some kind of prefix, I can just tell my tables will have it, my columns will have it, whoever will have this prefix. So you can define it here. And if there's something you cannot find already in the tool, you can always use these transformation scripts. So a transformation is changing what, if you have something in your entity relation diagram and you want to use information you have to create something inside the model, you can use these transformations. Like I have here examples where I'm using, let's see, I want to create an index for hash key and hash diff columns, or I want to have the table name in title case, or I want to change, this is a SQL Server world, I want to change my primary key index to non-clustered. So it's just a JavaScript piece of code. Or I want to remove the table abbreviations from the column, or anything like this. So it is, if it's not already here, this one is here, so you can have your object prefixes. But if it's not here, you can always create your own script. And actually, you can get a lot of help from our show here. So if you go and see the start page, this is a bug. It makes it very small every time I use this, but I still take the risk. There's the getting started page, where you can find community, you can find extensions, you can find related tools, and you can also find tutorials, demos, training, information, and so on. So there's a lot of places to find information. Data modeler on OTN, for instance. So you will find a solution even though it would not already exist in the tool.
The next question, is there a way to export preferences, templates, domains of one data model to another data model?
Yes. So depending what we are talking about, so some of these are, I will show you here an example. So for preferences, some of these preferences you can export and import. But what is the key thing here is that I have a place where I save all these things that I want to share with my users. I have defined here a default system type directory where I have all those files I want to share with other users. And I put these in version control. And everybody takes the files from version control to this directory, and the tool knows how to use them, including domains or RDBMS sites and so on. So this is the way to do it. Define this directory, define the files, put them in version control, and tell your users how to get those files from version control to this directory. And this is actually a very important place in the preferences. This is where you define what are the defaults for saving the designs or any of those other things. So this is a good to know as well.
That's good. Any tips on preserving domains between upgrades? I generally cannot remember where they were saved in the previous version.
Upgrades of the tool? Or
domains between upgrades?
Do you mean when there's a new version of Data Modeler?
Yes. The question says, any tips on preserving domains between upgrades?
Oh, domains, sorry, I didn't hear. Yeah. Domains is exactly what I just said here. So the domain file, oh, something with my ears. So the domain file should be stored here. And then whenever you do the upgrade of data modeler, it's always in the same place. It's still here, even though you upgraded data modeler. So the file, the domains are stored in a file. It's called domain something, XML. And if that is stored here and not in the default directory of SQL Developer Data Modeler, it will follow you. So just store it here and define this directory here, and you will have your domains.
Okay, next question. Is there a way to integrate the process that the user asks for with the logical model, something similar to Oracle Designer?
A thing I might like to do is requirements. So if I have a new requirement, I will define that requirement to my, let's see here, for instance, entity. There's a thing here called change request. So I would put here a change request for an attribute. They want to get rid of this attribute because they no longer use it. Or I would have it for my whole entity, saying that there's a request to have a new attribute for this particular entity, and so on. So I would probably use these change requests. And in my blog, there's a post about how to follow the change requests using reporting functionality.
Sure. One more question. What OS are you running SQL Developer on? Sorry if I missed this at the start.
Oh, I'm using Windows, but it doesn't matter. You can use also whatever. It works on different platforms, but I use Windows.
Okay. How to manage changes between models versions?
With version control. So whenever I start working with a project, I attach it to version control. Everything about version control is under here, team. So I attach it to Git or Subversion, depending on the customer, which one they prefer. And whenever I make changes, I save here my design. So everything happens in my computer, in my C drive. So I save everything there, and then I commit to my version control. And if there is a problem, I figure out that something went wrong, or they want to get a version something. By the way, when I commit to version control, I always somehow label it. This is version 1.1, this is version 3.5. When I do the compare I mentioned earlier here in the slides, different compares, I can compare the two models. I can bring from version control, let's say 1.1, to my laptop, again, to my C drive. So I will have 1.1 and I have the latest release, and I can compare them using these compare tools to see how are they different. And if there's something that I want to change, I accidentally removed an attribute, or I dropped the table from my design, I can actually get it back using the previous version. So this is the tool for comparing the designs and getting back whatever you lost, or creating a database of version 1.5 instead of 3.7.
Can I create table APIs?
Yes, you can. Absolutely. There's just a button you press here for the ORTs. It's difficult to pronounce, ORTs. So it's just a button you press and you will get them done.
Okay.
Yes.
Can we use data model for reverse engineering from physical to logical?
Absolutely. So the reverse engineering is something I use a lot because, to my surprise, a lot of companies don't have any kind of documentation of their databases. So the first thing I do when I go to a new customer who doesn't have any documentation, I reverse engineer. So actually what you can do, I will actually show it here. You can do this. You can use file import DDL file or file import data dictionary. And instead of saying compare, you will say a new relational model in the options. And that will create you the relational and the physical model of the database. And if you want to create the logical based on whatever just came from the reverse engineering, there's this double arrow here that will engineer to logical model. So that is automatically creating your logical model for you, the entity relationship diagram for your reverse engineered database. Then you can go to the logical model, do whatever needs to be done with it, engineer your relational, and get the new DDLs for your database. So you can kind of take it as reverse engineering and start maintaining your database.
One more question. Is there a tightly coupled integration between data modeler and quick SQL in Apex?
Data modeler and?
Quick SQL in Apex?
Quick SQL. I don't think so, but actually I'm not familiar with that because quick SQL is okay for, like the name says, quick things, but this is for really thinking about what you are doing. So, well, if I say integration, I would say if you create the database with whatever tool you created, you can always use reverse engineering to get it to data modeler. So whatever the tool is that you actually used for creating the database originally, it doesn't matter because you can always reverse engineer it to data modeler and start designing. And probably if I have it done somehow in the beginning to do some kind of proof of concept or something, I probably would reverse engineer to see what I had originally because there's probably some kind of idea behind the quick version of it anyway. So I would use reverse engineering and then I would start seriously designing the database.
All right. There are two questions in the support. So when will Oracle SQL Developer Data Modeler support Java 11 on Mac X?
Oh, any questions like that? Cannot say. Previously, the number one question was when is Git supported, and I always said hopefully soon, and now it's supported, but can't tell because what I like best with the team working on data model and SQL developer is that they prefer fixing bugs first, and when the bugs are fixed, then they bring new functionalities. So I think that is admirable. So I really like bugs fixed first.
Yeah, and we might want to point to the statement of direction for any such questions as well. The same question, similar question, when will SQL Developer Data Modeler support OX X Catalina? I think you have already answered a similar question.
Yeah, I answered that too. So I don't know. And even though I would ask Oracle, they still wouldn't tell me because they have ideas when they want to do things. But if there's a serious bug found, they fix it first and this is postponed. So, yeah.
And the last question, I think we answered this one as well along with Quick SQL. Is there a plan to integrate data design on Apex?
Oh, that's something you should probably ask the Apex team and the SQL developer team. Well, it's somehow already integrated because it's in a database. Everything is in a database. So when I have my DDLs and I create my database, that's the basics to start with Apex. So the database is kind of the clue here. So they are integrated using database.
Right. I don't see any more questions in the chat window, so I think we're all good. Thank you so much, Heli. Thanks, everyone.
Thank you.